Howdy, howdy. Welcome back to Deep Dive. We are back here again to talk about something new. So, we're talking about interfaces today. I have a new project set up just for this. So, we'll just kind of dive into interfaces. If you've watched a few of my other tips and tricks videos, you kind of saw that we kind of glazed over some interfaces, or we kind of come to some concepts where interfaces might have been nice to use instead of implementing. And yeah, I think we kind of quickly discussed like subclassing in some cases. And I think it was the video that we did where we had an encryptor and had factories and stuff. So I just wanted to kind of give a brief overview though, as we kind of dive into interfaces. And once again, I think this is a pretty deep topic. I'll plan on doing a lot more videos on this, maybe a course on it. But just this is a pretty nice brief overview of what interfaces are and how I like to use them. So, what are they? An interface, you can think of it as kind of the blueprint of how you expect a class to work. So, I've told you before, a class is, you can think of a class is kind of this organ. It's kind of, or it's a component. It's a tool for doing something to something and then spitting out a result. So you might always think that that's a function. Well, a function kind of helps this tool do that, but a function itself is not really a tool. It's a function of the tool, right? So, and a class, and then we distinguish a class from something like a struct, which we mainly use that to just store data. It can have some functions that we use to manipulate the data a little bit, but we mainly do all of our main manipulation inside of a class. And so it can be really useful to tell people what your class is going to do before you even code it out. So you can think about doing an architecture kind of review. And so if you've never done an architecture review, if you've never done that before, what that essentially is you're about to do a big feature. So say you're about to build an app. So, Twitter, once again, is just a very popular example. You're about to go build a Twitter clone. And your Twitter clone is going to take over the internet, and you know that it has a lot of moving parts to it. And before you just jump into the code base, you want to lay out all the work that's going to be involved to get the first POC or the proof of concept going. So with laying out that proof of concept, you start to lay out that it's going to have a back end here, it's going to have a front end here, and then it's going to have in the middle all this these API endpoints that are going to go here, and this API is going to let you create a user account, and this API is going to let you display all the posts and stuff. And then to get the post, I have to store the pictures in this location, then retrieve them with this kind of thing. And so you end up having this giant diagram that you end up making that shows how everything connects to the other, and how you use the app, how you make it expansible, how do you make it something that can grow and evolve to address more customer needs. And so you draw out this whole big diagram. So, and that actually would be a great video to show kind of how I go about building my kind of architecture. And so once you finish building out this architecture, now you start to get into the coding phase of it. And before you start coding it out, you kind of want to do a technique I like to call just hooking up everything. So it's almost like hooking up carcasses to each other. So these carcasses are not really, or maybe it's really hooking up the skeleton, right? So before you start to add all these classes together and start giving them all functions, I like to just build the skeleton first, make sure the skeleton looks pretty good. And once for me, I've seen a few architectures, so I can kind of tell, oh, this skeleton looks pretty solid to me. But if you haven't built a few architectures yet, you're not going to be quite used to thinking like this. So don't be afraid if this is over your head, but come back to this video, watch it later, and it might start to make a little more sense, just what I'm talking about. But interfaces are really pivotal to just kind of building the skeleton of your program. So if you can just kind of remember that, and then when you come back later and you define your interface as classes, then that's kind of adding all the muscle and meat to your program, giving it all the functionality. UI maybe is skin. Okay, I'm not going to push that analogy anymore, but That's kind of what an interface does. It lays out the skeleton of your program. So in a very micro view, which is just an individual class, an interface just gives you a skeleton of how that class works. It tells you, hey, this. So let's just take, for example, what we're going to code up is an encryption interface. And so this encryption interface tells me, hey, I need some method to encrypt. I'm not going to define it for you, but I need some method that will allow me to encrypt something, right? I need a method called encrypt to be defined, and maybe I need a method called decrypt to be confined to be defined. And so, that's pretty much all it demands from you, is that these things be defined. And with those things being defined, other people can start to take dependencies on this interface without it even being coded. So you can think that if I've got an interface defined, let's go back to our Twitter example. If I've got an interface defined for some service that's going to return images to me, well, then I don't have to wait for someone to code up some retrieval engine that stores pictures inside of a CDN and then retrieves images from that CDN. I don't have to do all that work yet. Instead, I can just say, well, I'm going to assume someone has defined this interface for me, and I'm going to keep going with my work where I'm now displaying that all that image to the user, right? Or I'm giving the user the ability to change their image. So I can start coding on a completely different part of the app, and that other part that was retrieving the image hasn't even been coded yet. So I'm pretty nuts about interfaces. I love them. They are absolutely the ideal way to code, and it allows you to kind of lazy code if you're like me, because I can say that, well, I'm going to assume I can solve this problem later. And as you get, a little more advanced in coding, you can start to understand what are good assumptions and not. So you might not assume that you can do some complex ML problem. You might not be able to really make that assumption. But you can maybe assume that, yes, I will figure out a solution to store images somewhere later on. I don't want to do that right now. I'm tired. Maybe it's late on a Sunday evening and you're coding this project and you're just like, I don't want to work on that project today. I'm going to assume something is going to supply that to me in the future. I can code that up next weekend or something. But right now I want to focus on a different part of the app. So the interfaces give you that freedom. So that's really a core benefit of having interfaces in your code, is that it allows you to not only kind of architect out your system before you even build it, but it allows you to be a little lazier with implementing different parts of your system, and even allows parallelism for your project. So it no longer is that if you're building this feature, so say that you're working with images once again, I don't have to be the only person that can work on this feature at this moment. What we can do is we can do an initial PR that puts out all these interfaces, and we can all agree on the schema for these interfaces. We can put that PR out, and then 5 other people can work on 5 different interfaces and implementing them out in classes. And then maybe someone else later makes that 7th PR that just joins everything together nicely. So if you've coded it really, really amazingly, you don't even have to add that last PR that joins everything together. So yeah, like I said, that is a huge topic. Do not think that we're going to discuss all that today, but we're just going to go through a very brief example of one of the cool things about interfaces and how I like to use them just when I'm starting out in a project. So diving in, I can't remember the exact video, but we talked about in one of these other tips and tricks videos. So I haven't made that many just yet, but in a previous tips and tricks video, I talked about making this user factory, and we also had this alter ego factory. And that the user factory and the alter ego factory used a common method out of the encryption class. I actually almost called it an encryption library, because you probably would be using someone else's encryption library. You probably wouldn't be making your own encryption engine. So they were both using the same function out of an encryption class, and the way we kind of solved that problem was we defined our own encryption class, and we instantiated that object and passed that in. And one thing to note there was that we were locking So one thing that was great about that option that we did was we were allowing something else to create that encryption object for us. So the user factory and the alter ego factory, their job is only to create the user and the alter ego respectively. Their job was not to create an encryptor, because if the user factory creates an encryptor, well, now there's a question of, well, should it share its encryptor with the alter ego factory? Now you're thinking about subclassing, and that was just a messy problem, not really one that we want to get into. And so we said, well, they can both share the same encryptor. It's a pretty static call. Doesn't really have any influence on the other, so they can share it. So we're going to pass it in through the parameter, through the constructor, and the constructor stored it as a field variable, and then that variable was accessible by the create methods in both of the factories. So that was a pretty cool and good option to do, is pass that component in through the constructor. But one thing that we did, and this is a common issue that plagues a lot of code, is that we restricted the encryptor to one type of encryptor. So say that we need to change that library in the future, or that there's a bug, and this is very common, that someone finally cracks this form of encryption for this. So I think, I forget all the SHAs, but say someone breaks SHA-1. I think someone has broken SHA-1 already. Even though it's a really good encryption, someone breaks it, cracks it, and so now we can assume it's compromised, and people can crack those encryptions pretty quickly and figure out the password pretty quickly. Well, because they've broken it, now we're saying, okay, well, I actually want to upgrade my encryption to SHA-256 throughout the entire program. Or there's this new crazy SHA-1060 or 1080, and I want to include that throughout all my programs. So because we hard coded this encrypt class, we either have two options. We can go adopt a new class that has this SHA-1080 function inside of it that encrypts with SHA-1080, and we can go add that class as the parameter to all of our classes, and then we can change the piece of code that allowed it through. Or we can maybe add a new method inside of it that's encrypt 1080, and apply it that way. So that's kind of the two options available to us. But what would have been nicer is if we had passed in an interface into the constructor, and then that way all we would have had to do was switch from the SHA-1 class, for instance, that was cracked, had the crack algorithm in it, and we'll switch from that class to the SHA-1080 class that we were passing in the builder piece of code. We could have switched to that, and then we would have been done. The work would have been done. We can move on to the next problem. We send that PR up, and we're done. So that's the power of an interface. And I don't have that code pulled up right now, but I'll just kind of run through what I'm talking about. So here. So what we're going to do is we're just going to code out the encryptor, kind of just a basic encryptor class right now. Okay, so basic encryptor has a basic constructor, and we just have it return a string, and we give it a method called encrypt, and all it's going to do is return, it will take in some string of data, and it just returns data.upper. So we have this class that does this, and so if you remember in the other one, I also had a builder class. Oops. And here we will do, let's think of something to encrypt. So we had this user factory encrypting the password. Maybe let's just call it password generator or something. Okay, cool. So over here we'll have builder, and we'll have a method called build, and what it will do is it will build, it's going to generate an encryptor, and maybe it'll also generate a new password generator. And then what it's going to, and what password generator is going to take in is an encryptor. And then, yeah, you'll just kind of see what I'm talking about. We'll say equals maybe pass gen dot generate password. We'll make it do something like that. Okay, cool. And so, okay, we'll go to password generator, and let's just quickly make that method. String generate password. And this is going to return. So let's just say that it has a random length. And usually I could be a stickler about, oh, the length should be a UART, but you know, that's to each their own. Let's just make it 24, and then we'll say, we just need to generate this password. So, I think I can do random. There's multiple ways to go about this one, but this might be the easiest. String password is, let's do a string array. Password equals new string length, and then I'm hard coding length right now, but we might pass it in the future. Who knows? And then we will return. We'll go through it. So for we'll do a for length int I equals 0, I less than length, I plus plus, and then for password I, we will equal, I think we need to make a new rand. So random rand, new random, and it's going to be some rand dot, yeah, and then we could do double times 2. It's like, I think we could do rand dot next int modded by 256, cast that to a char, and I believe that should give us what we want. It's greater. We applied to operands of type method group. It's greater than. Oops. It is a method. Now what? Char to string. Oh, you're funny. Well, then I will call your to string. Okay. Cool. I guess I could have just made this a char away. All right. And I don't have to do this. And then I will return password dot to string and turn this to char. Yeah, okay. Possible null reference return. Password equals this. I think I could do string.empty. Cool. That was a null check. All right, I went quiet on that one. Sorry, there was a lot going on there. So what I did was essentially build a just build a random password generator on the spot. And what that's going to allow us to do is to kind of have some fun. Now we get some actual, we'll generate a random password of length 24. And it's actually expandable. So in the future, we might add in that. But yeah, I'll kind of show you how to do that as we go in. So So what I'm doing now, I'm just going to store the encryptor into this class. And now we can move through this. So now we have our password generator. We go back to our builder. That was the password generator. Now we have a function that describes generate password. So we are good to go. No complaints here, right? So if I now make if I make an adjoining class, or sorry, if I make a new project, and I'm just gonna make this a test project. We did use NUnit recently. I actually don't mind it. So this one's gonna be tips and tricks tests. And we will make, I actually didn't code inside of one. Okay, anyway, that's fine. So I'll just pop onto this one, and this is gonna be test builder. So what I need to do is add the reference to the project that we made. Pop, select, okay, then we'll do a using, oops, oh, it has weird namespace. Okay, so using, we're using the tips and tricks dot, okay, we actually aren't inside of a project. Alrighty, we're just out in the open today. And so let's go ahead and make our builder. Var builder equals new builder. And we're just going to go ahead and build builder.build. And we'll just step through with the debugger and show you what things look like so far. Videos incoming on how to use a debugger, by the way. So we go ahead and build this project. Over here, our test should appear, and we will run, right click, debug this test, and pachinko, we are here. So here we are. We just ran our build code. We built the encryptor fine. We created a new password generator, which took the encryptor in. Right now it's not using it, but then here we're getting to this line of code. We run that line of code, and now here we have a password. So let's actually see what it looks like. Oh man, I do not have my immediate window. Okay. System.char. Tell me what passes. Oh, that's interesting. It printed out. It actually printed out like that. So that's my bad. Let's pop into here, F12, and we can see that we can't use the toString method. We actually need to convert this char to a string. So let's see if there's a method inside of it that I was actually supposed to use. If there's like an output, get length, it's read only. There's a toList. toList is interesting. Union. Okay, so yeah, those are all kind of array functions. So I wonder, ooh, there's a zip, nice. So what I will see, we'll pop to the internet and char to string C sharp. You know, in these cases, it's just easier to go right back to the solution you already had. And honestly, I way made this harder than it needed to be. What we can instead just do here is make a string password, and we'll return the password, and we will say password plus equals this. Okay, cool. Looks like it is okay with that. We run our tests. Let's pin you. Oops. Okay. Let's debug this test. And we're here now. We run to the next line. And there we go. So here we have our crazy password. It's in this char notation, so don't be intimidated by that, but that is as we expected it to be. It is some variation of 256 characters, all output into string format. So we got our password generated correctly. Now let's use our encryptor method to inside of this. So say that after we finished our generating the password, we actually want to encrypt it. So we'll just use our encryptor to encrypt this password. And we'll be on our way. So we let's do another run. I'm not finishing any of my test runs. Okay, so let's do another run, debug that. Jump into the next line, and everything. I know this is hard to see. And maybe it wasn't very smart to use characters, but we can see that we do have some uppercasing. Well, it didn't fail. So we know that some operation did happen to try to uppercase. That's actually a good test out of the uppercase function. Maybe to make this demo better, I should have limited it to just alphabet characters. But anyway, I think we kind of see that it used the encryptor, and it was good. So now let's just say that, or maybe let's just say that, right? So to upper doesn't really work on a lot of, like, 26 characters out of the 256 available to you, like in ASCII. So you say that, well, my encrypt method doesn't work on this, and so I want to actually improve it and make it work on all kind of characters. So I've come up with another algorithm. So I go over here, and because I can't really adjust the encryptor class, I have to go make my own encryptor. So I make a better encryptor. And I come over here, and I'll make it just as easy to use as the encryptor class. So I'll even title my functions the exact same way. And I'm going to come over here, and I'll take in string data just like the other encryptor class. And this time, what I like to do when I have some piece of data, I don't know, mine is better because I actually turn all the data into ones. So I'm really efficient too. So all I do is I get var length equals data dot length, and all I do is I return back. Oh, darn it, it doesn't have. I just return back a string that's all just these number of ones in that string. In Python, this is so easy, but and C#, there's no real great easy way to do this. So we'll say output equals this, and we'll say for and I equals 0, I less than length, say I plus plus, and we'll say output plus equals 1. And we'll just go ahead and surround it in quotes, and we return the output. So I have this new encrypt method. It's cutting edge. Nobody can break into it, and I'm feeling pretty good about this. And so I say, oh, well, okay, great. I built it. I've tested it. Now I need to actually go about integrating this into my code base because I have this better encryptor class. So I go over to the builder, and I'm here. I see that, okay, this is the only place that the encryptor class gets instantiated. So I just go make a better encryptor object just like that. And I'm like, okay, I'm instantiating it just like the other encryptor. And now all I need to do is just pop it in here, right? It has the exact same endpoint. It should be able to run, and no, the compiler complains. It says that that's not the same type of class. It can't convert between the two. And this is where it can be tricky, right? When you say, oh, it can't convert between the two, you start to think about subclassing and, okay, well, maybe better encryptor can actually be a subclass of the encryptor class, right? That solves my problem, right? I can go right back over here to builder and everything builds. And actually, if I go ahead and run this now, I'll stop running this. But if I run this and I run this test, nothing's really going to fail. And actually, if I go debug this test, and we just look at the password that gets generated from here, oh, it didn't turn to ones. Oh, that's actually interesting. It probably ran its parent. Better encryptor. Let's actually go inspect that. So if we pop into here, we build this method. Let's go see which encryptor method it calls. So, okay, so it went to the parent class encryptor method. So it did to upper instead of doing the child's override class. And actually, that's probably the reason we didn't add the override distinction in front of it. So anyway, like I said, so there you go. You would be solving those kinds of issues, and and now you have this strong tie. You have this strong tie that's saying that wherever I use the encryptor class, I should now be able to use the better encryptor class. And that may or may not be true, but it's like a very, very strong tie. It's a very strong relationship that you don't necessarily want to maintain forever. So there is a looser relationship you can have, and that's just an interface. So if I go back up here to this builder and I look at just kind of where the encryptor class was being used, like how it was being used. So I come here and I just see that, okay, really the only endpoint that was ever being used was this encrypt endpoint. Oh, and maybe that's the issue is, once again, a great example. So, my encryptor defined a lowercase encrypt, function, and but I defined and I accidentally defined an uppercase encrypt function. So if we want the compiler to help us out here and us not be bashing our heads against the wall, it would be better to just make an interface between these two and just say that these two share an interface and that's it, right? They're not necessarily child parent or anything like that. They don't have that strong relationship, but it's just that they share an interface. Let's just see if that did indeed fix the issue. Oh, okay, it's gonna fail here. Let's go see if that did fix the issue. So when I F12, oh, okay, I'm still going to the wrong place. Let me just look at password. Yep, and it still does. Okay, so like I said, we don't want to spend all day debugging that because that's not actually our issue. So now, yeah, like I want to tie these two together with an interface. So I come over here and I go to add, you can go to the new class, and there's this empty interface. In here, I always denote I in front of all your interfaces. You'll see that as a common pattern that you in code bases to have I that just says this is an interface, this is a mapping. And I just say here, I encryptor. So now anything that does any kind of encryption can just inherit from this interface. And so, as I mentioned before, the main endpoint that we cared about was this encrypt endpoint. So, and this, what it took was it took a string of data. And so you will now implement a method exactly like this. And it has to be public or it has to be internal, but yeah, you need to go implement this method wherever whatever class says that it inherits from this. So when we go to the encryptor, just because they look, it conforms to the interface, but the way that we tie it to the compiler, we tie this enforcement to the compiler is just going up here and just adding this notation onto it. So cool, everything checks out. Sometimes I know for me, I get like the naming just wrong sometimes. Oh, okay, yeah, see, I'm returning the wrong type. So encryptor returns a string. Cool. So yep, compiler says that we are checking out, we are good. If I go over here to better encryptor, and yeah, actually we can see, so I was supposed to use the new keyword over here, but now I can, instead of inheriting from that class, that pesky class and dealing with that, instead I'm going to just inherit from or I'm just going to say that I'm implementing this interface, and boom, just like that, the error goes away. We don't have that strong parent-child relationship with this class because I'm on the same level as the other class. And so, and that's why you really would want to use an interface over a class, a parent-child relationship in a class. So cool. Now we have two classes that are both inheriting from this encryptor. Anything that calls them is guaranteed to have this endpoint. That is the promise that an interface gives you. It tells you, it just says that, hey, if you use a class that says that it inherits from this or it implements this interface, you will always have this endpoint to call from. So this is really handy for us. So when we go up here to the builder, we now can have a much looser contract with what we take in and what we take in as an encryptor. So the password generator right now has a strong contract that says that I only accept an encryptor. Not only am I accepting only encryptors, but I can only accept this specific type of the encryptor. And the way to get by conventionally might have been, well, I'll just subclass encryptor to get past this, but that presents all kinds of other issues and all kinds of strong relationships that you have to maintain. We'll talk about those in the future. But I'm just like, well, really what I need is just something that will encrypt something for me. So I don't really care if it is an encryptor. I just want something that promises that it encrypts something for me. And we'll talk about that in like a broader course. But you could pass something in here technically whose main purpose is not to encrypt something. You could pass something in that secondarily encrypts something, but it will, as long as it implements the interface for encryptor, has that little I encryptor tag on it, it's good to go. So all I'm going to do here is just add the I, and boom, now I'm saying, hey, I accept any kind of encryptor. So I don't just accept this specific type of encryptor. I accept any type of encryptor or anything that promises that it implements the encrypt method or whatever the contract specified by this interface, anything. And hey, sometimes you don't even want to define anything in this interface. You just want to say that I only want to accept things that will pass this contract, whatever contract is specified here. Once again, this is like an open kind of thing, and this is great as an architectural tool because you might not even know what this interface is. In the future, this thing might have 100 methods. I would never I would say never advocate to code out 100 method class like that. That sounds awful. But you could have an interface in the future that has 100 classes. You don't know. You haven't started to implement anything yet. But as long as you tell this class that, hey, I promise that I'm going to give you some kind of encryptor that comes your way. I don't know all the specifics about it. I don't even know what the endpoints are, but I promise you I'll give you some kind of encryptor. You can just pass that in and you can be on your way, moving on to the next problem. And then yeah, you come down to the generate password and you say, hey, could something encrypt something for me? So can I go change the contract and ask it to supply me an encrypt method and use that? And you move along that way. So like I say, that's been done. Now we go up to our builder. Build errors are gone, and it's easy enough. Encryptor and better encryptor don't know anything about each other, right? So for our other passgen equals new password generator, better encryptor. So here you have two password generators that have two different encryptors, and the encryptor engines don't know anything about each other, right? And they move along just very easily. But like I say, I'm not going to keep moving down that path. But I just wanted to show you just how nice it is to be able to swap these out very easily. Oops. It's very nice to be able to swap these out very easily and move on with your day, move on with your coding day. So now if I set a breakpoint, and now I'm 100% sure I'm not going to have that two upper issue that we were having before. I go past you. And now if I look at my password, look at that. I have all ones. That's a beautifully, perfectly encrypted password. There will be no one that can ever crack that. Honestly, that's a big lie. But yeah, anyway, now we have it working. We know that the proper encryptor is being used. We know that our better encryptors generate our encrypt method is being used because it outputs ones for the length of the password, and we're good to go. So I'm sorry we went kind of around the world on that one, but I like to make these kind of very realistic coding demos for you, and it even sometimes shows APIs that I forget. But that just was a demo of how to set up an interface, or just kind of a motivation for why we like to use interfaces. It just makes our lives a lot easier to come back later and implement or to swap out kind of interfaces. So now in the future, the only work that you would have to do if you had an even better encryptor, you could come along later and implement that encryptor. And so like I said, you would come here, even better encryptor, and you would come along and you would instantiate it here. Oh, this is awful to type. And you would instantiate it here, and you would swap this out, and then you're done. You complete the PR, you move on, right? You would, because you know that because this thing implemented this interface, I'm good to go. I can trust it completely because I know that whatever this password generator, I know that it built all of its code to this interface. So it didn't use any extra functions that were not inside of this interface. Whereas if it had used just the normal encryptor class, well, the encryptor class can define a whole bunch of stuff, right? It could define something here, do other stuff. It could define some method here that does this, and this is outside the specification of the interface. And so now I can't reliably switch out things anymore. But because I've locked it to this interface, now I can always switch out this parameter with anything that implements that interface, and I can be on my way. And so that's really good. So but yeah, that was just a very quick, try to be quick, at least overview of interfaces and just some motivation as to why you might use them. In the future, I think I'm actually planning on talking about abstract classes next. So we'll kind of talk about what the differences between those two are and why you might want to use one over the other. So hope to see you back, and that'll be it for today. Bye.